Hi folks, it's Dr. P. I want to talk a little bit about Boolean algebra. Boolean algebra forms the basis for just about everything we do in digital systems. I understand that it's difficult and students don't generally love doing it. I didn't love doing it when I was a student either. In fact, I didn't really learn this stuff until 2016 when I got hired to start teaching this class. First, understand that this is a stepping stone. You need to be able to understand Boolean algebra before we can use shortcuts, but those shortcuts will come and make your lives much easier, and then we'll be building on to bigger and better things. The way to get better at Boolean algebra is practice. There are example problems in the textbook. You will get some practice in the homework and in your labs. I'm sure you can do a Google search for even more practice problems if you want. Once you practice a lot and do lots of example problems, you start to pick up on some tricks and shortcuts that help. Here are some things I've picked up on. To make the best use of these tricks, try them out while you practice. Without practice, your skills will not improve. First, let's look at the uniting theorem. The uniting theorem tells us that xy plus xy prime is equal to x. If you look at the uniting theorem, you'll notice that both terms have the same number of variables. This has two variables, and this has two variables. All of the variables are identical except for one. They both have an x in common. And the term that is not common exists both in primed and unprimed form, right? Both other terms have a y, but one of them is primed and one of them is not primed. We could expand the uniting theorem to include even more terms. For example, x, y, z plus x prime y, z. Both of them have three terms. They share a yz, and the term that's not in common is the x. It's unprimed and primed. This would be equal to yz. Or we could even do a, b, c, d, e, f, for example, plus a, b, c prime, d, e, f. They have the same number of terms. They share terms in common, and the term that's not in common exists in unprimed and primed form. This would be equal to a, b, d, e, f. If the two terms you're looking at have a different number of variables, or there's nothing primed, then uniting is not an option. Now let's consider the absorption theorem. Absorption tells us that x plus xy is equal to x. You'll notice that the first term, which in this case is an x, exists completely within the second term. And the two terms have different lengths. This has one variable, this has two variables. Essentially, if you can factor one term completely out of another term, then you have an absorption step. This would look like factoring out a term and ending up with 1 plus something. Here, if I were to factor out an x, I'd end up with 1 plus y. And we know that with the rules of an OR gate, anytime you have 1 and literally anything else, that 1 is going to win out and you're going to have a 1 on the output. So if I were to take this, I would wind up with x ANDed with 1, which we know winds up with x. So absorption happens when two terms are at different lengths and one term completely contains the other. However, this term does not necessarily have to be one variable long. You could have something that looked like this, AB plus ABC prime, right? You can both factor an AB completely out, and that is the entirety of this term. I would wind up with AB, 1 plus C prime, which means that this is a candidate for absorption. We would wind up with just AB. So don't limit yourself to just terms that have a single variable, but terms that one of the terms completely can factor out of another term. That's how we know we have an absorption step. Next up is elimination theorem. Elimination is the hardest theorem for students to find. It's trickier than uniting and absorption. Elimination tells us that x plus x prime y is equal to x plus y. The one thing that we have to look for is a primed term. We can't do elimination if there are no primes. The thing about elimination is it looks almost like absorption, but this shared term exists in its unprimed and primed form. The prime can be on either term. It doesn't have to necessarily be on the longer term like the theorem says. For example, if you found a prime plus ab, this would be equal to a prime plus b. Just like with absorption, the first term doesn't have to be just one variable long. You could have something like ab plus ab prime c, in which case you would wind up with ab plus c, right? Because this term and this term both exist. So elimination happens when two terms are different lengths and the shared term is complemented in one of the terms. Again, it's a little trickier to find, so you're just going to have to do a little bit more work. Last but not least is consensus theorem. Consensus is like the black sheep of the four theorems. It's very useful, but it can be very tricky to find. Consensus tells us that xy plus x prime z plus yz equals xy plus x prime z. This yz term is called the consensus term. In fact, the consensus term is not giving us anything new. It's not providing any unique information that we can't get from these two terms, which is why we can remove it from our Boolean algebra expression. The first thing to know about consensus is that there must be at least three terms in an expression for consensus to even be a possibility. And there must be a prime somewhere. Without those criteria satisfied, you can forget about consensus. The best way to find consensus terms I've found is to use a consensus table. Let's use a consensus table to see if there are any consensus terms in AC prime plus ABD plus BCD. We know it's a candidate for consensus because there are at least three terms, and there's a prime somewhere. What I do is I make a table to look for all of the variables and their complements. We have 4 variables, so I'm going to have 4 rows in my table. I'm going to look for all of the terms that have an A. There are 2 of them. I have A, C prime, and A, B, D. There are no terms that have an A prime. If you look, we basically take whatever's ANDed with the unprimed term and that with whatever is ANDed with the primed term, and that gives us our consensus term. Because I don't have any primed terms for A does not contribute any consensus terms. If we were to look at B, we would again see that while we have terms that are ANDed with B, there are no terms that are ANDed with B prime. So B, again, is not going to provide any consensus terms. Now we look at C. There's a term with a C, and there's a term with a C prime. If I were to AND together these two things, I wind up with A, B, D. A, B, D is therefore a consensus term, and I can remove it. Now that I've removed that, I only have 2 terms in my expression. It's impossible for me to have any further consensus terms. So my answer is going to be AC prime plus BCD. Consensus table is really the best way that I've found to do this. If there were a shorter way to do it, I would be using it. But if you find one, let me know. I hope this helps. Remember, practice is the best way to become proficient. Until next time, stay well.